Alright, third test of the quarter, 11th test of the year. This test is coming up this Thursday, this Friday. I hope you are ready, students. This test is all about factoring. I want to burn through this review, as always, as quickly as possible. And so I'm not going to waste time here. I'm going to get right down to business. Let me take a sip of my 3-day-old coffee first, though. Alright, now we're ready to rock and or roll. Directions determine if each monomial is prime or not prime. Okay, a little vocab. You'll remember that if something is prime, it can only be divided by itself and 1. If it's not prime, then it has many factors. So if you're able to factor something, it's not prime. If you can't figure out how to factor something, chances are it's prime. So, what we want to do is we want to find the prime factorization of each monomial. So what that means is just keep factoring until you can't factor anymore. And then the result that you end up with is called the prime factorization. So let's take a look at what that looks like. Here we have 78, a squared b to the fourth. This says 78 times a times b times b times b times b. So 2 a's and 4 b's. Now 78 is not a prime number because it's even, so we know it's immediately divided by 2. It can be divided by 2. So 2 times 34, is that right? Let's see here. 39, I'm sorry. 2 times 39. Okay. And times a times b times b times b times b. A times a is a squared, that's how we factor that, and b to the fourth is the same as multiplying b times itself 1, 2, 3, 4 times. Okay, we can still keep factoring. 2 times now 39, 3 and 13 are factors of 39, and we can keep writing a times b times b times b times b. So we have our factor tree all worked out here. We cannot factor anymore. Therefore, this row right here is the prime factorization of our original 78 a squared b to the fourth. Okay, let's come over here. 562. That's an even number. We can divide it by 2. 2 times 281 times x times y cubed. And 281 is prime. I looked it up on Wikipedia right there. 281 is a prime number. And so this is our prime factorization. 2 times 281 times 1x times 3y's. Y times y times y. Okay, that's the prime factorization. Let's move along here. Alright. Find the greatest common factor, GCF, greatest common factor, of each group of terms. So we have 4y cubed and 8y. Alright, so what we want to do is we want to figure out, first of all, we want to figure out the factors of each one of these terms, and then we want to take a look at the factors they have in common, and then pick out the greatest common factors. So let's factorize this. So 4 times y times y times y would be 4y cubed, and 8y would be 4 times 2 times y times, oh no, just times y. So there's the factorization of 8y. And when we take a look at what we have here, I see a 4y over here, and I also see a 4y over here. Because we could also write this 4 times y times 2. And so here is a common factor, 4y, and here's a common factor over here, 4y. And these right here are both common factors to each one of these, and they're also the greatest common factor. And you can see that easy just from looking at this. Well, what number can we divide by each of these? Well, 4 can go into both of them, and y can go into both of them. So 4y is the greatest common factor for both of these terms. We can take a look at 4 also, and I'm going to do 4 in a little bit different way. I'm not going to factorize it. Let's just kind of talk through it. Let's see here. Let's first I'll kind of no, I'm not going to do it that way. Let's just talk through this. Okay, so let's look at our numbers first. We have 3, we have 12, and we have 6. Okay, what is the greatest factor that can go into all 3 of these numbers? Well, it looks like it's 3. 3 can go into 3, a maximum of 1 time. 3 can also go into 12. 3 can also go into 6. So it looks like 3 is going to be a common factor, the greatest common factor. Now let's look at our x's. Okay, well, we have 2 x's here, only 1 x here, and we have 2 x's here. So what is the most amount of x's we can pull out from each term evenly? Well, they all have x common to them, but there's only 1 x here, so there's a maximum of only 1 x that we could pull out from each one of these terms. This is all stuff we've kind of discussed in class. Now let's go to y. Let's look at our y's here. Okay, there's 1 y, there's 3 y's, there's 2 y's. So again, kind of similar story. Y is common to all of these terms, but what is the maximum number of y's we could pull out from each term evenly? Well, even though this one has 2 y's and this one has 3 y's, since this term only has 1 y, we can only pull out a maximum of 1 y. And let's move along also. I see a z here. Well, I don't see a z here, and I do not see a z here. Therefore, z is not a common factor. Z is only a factor for this middle term, but it's not a factor for this first term or the second term. Therefore, it is not a common factor, and so should not be included in our greatest common factor. So 3xy is the greatest common factor for number 4. So you can either do it this way. You could break down the whole factorization and point out what common factors there are, or you can kind of just go term by term by term and see what is the greatest common factor for each little number or variable. All right, number 5. Number 5 is it's one of our special cases of polynomials, of factoring polynomials, because this, number 5, it's a perfect square trinomial. The reason it's called a perfect square trinomial is because the area that the trinomial represents, 9x squared plus 12x plus 4, is a perfect square. And we can tell that 2 ways. Number 1, the context of the problem says we're finding the area of a square. So that means that both the side and the length are going to be equal to each other because this shape here is a square. And so what we do for our special case is that we look over here and we check 2 things. Number 1, is this first term a square? Meaning, can we take the square root and get an even result? Yeah, if we take the square root of this first number, we get 3x, because 3 times 3 is 9. X times x is x squared, so when we take the square root of that, we get 3x. And then when we take the square root of positive 4, we get a positive 2. And so we can start to see that this possibly could be a perfect square. We're going to need a factor to check to make sure that our last terms add up to 12x. But so far, it looks like we're on the right track. So let's try this. So then what we do is then we'll take 3x plus 2, and we multiply it by itself. 3x plus 2. And so let's see what happens. 3x times 3x is 9x squared. 3x times 2 is 6x. 2 times 3x is another 6x. And then 2 times 2 is 4.